Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.104. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. Ohm's law will also be utilized while solving this problem. According to this law, voltage across any resistance R is the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.104. Find the value of voltage VA and resistance RB in given below figure, such that the value of voltage V1 is 4 volt. This is the circuit diagram of given problem. Inside this network, we have to find the value of resistance RB and the value of voltage across this constant current source labeled as VA. So without wasting time, let's proceed towards the solution. First of all, current through this resistance will be calculated because voltage across it is given. So using Ohm's law, current through this resistance will be equal to 4 volt divided by 2 kilo ohm. The value of current will be 2 milliampere and the direction of current will be downward because in order to make this terminal positive, current should enter from this terminal and leave from this terminal. Now we will apply Kirchoff's voltage law inside this closed loop to calculate voltage across this 1 kilo ohm resistance because voltage across other two elements in this closed loop is known. For that purpose, we are assuming the direction of current in clockwise direction, and according to this assumed direction of current, voltage polarity notation across this 1 kilo ohm resistance is marked. Write KVL equation for this closed loop. Start from here. Current entering terminal is positive, so voltage across 1 kilo ohm resistance will be taken with positive sign. Next, current entering terminal is negative, so 8 volt will be taken with negative sign. Next, current entering terminal is positive, so voltage across this 2 kilo ohm resistance, that is 4 volt, will be taken with positive sign. Subtract 4 volt from minus 8 volt, the answer will be minus 4 volt because larger value have minus sign along with it. And place this minus 4 volt on the other hand side of equal to calculate voltage across this 1 kilo ohm resistance, that will be equal to 4 volt. After getting the value of voltage across this resistance, we can calculate current through it using Ohm's law. Equation of current for this branch will be I is equal to 4 volt divided by 1 kilo ohm. So the value of current will be 4 milliampere and the direction of current will be upward, entering from positive terminal and leaving from negative terminal. Modify the network by indicating current through this branch along with its polarity. Now current through this branch is known, that is 4 milliampere, so we can calculate voltage across this 4 kilo ohm, that will be the product of 4 milliampere and 4 kilo ohm. So the value of voltage will be 16 volt and polarity notation of this voltage will be positive terminal here and negative terminal here. Now this 4 milliampere current and this 4 milliampere current both are entering on this node. So their accumulative current, that will be equal to 8 milliampere, will be leaving from this node through this branch. Similarly, current leaving from this node is 4 milliampere while the current entering is 2 milliampere. So 2 milliampere current should enter from this branch in order to leave 4 milliampere current from this node. So the value of current through this branch will be 2 milliampere and it will be entering towards this node in order to justify Kirchoff's current law on this node. Now on this node 5 milliampere current is entering while 2 milliampere current is leaving. Remaining 3 milliampere current will leave through this branch in upward direction. Modify the network by indicating current through this branch. Similar case will be here. On this node 8 milliampere current is entering while 2 and 5 milliampere current are leaving. Remaining 1 milliampere current leave from this branch in upward direction. Modify the network. Now we can calculate voltage across this resistance and this resistance because current through these branches are known. First of all, voltage across 6 kilo ohm resistance will be the product of 3 milliampere and 6 kilo ohm. It will become 18 volt and polarity of this voltage will be positive terminal here and negative terminal here. Similarly, current through this branch is known, so voltage across 2 kilo ohm resistance will be the product of 2 milliampere and 2 kilo ohm. It will become 4 volt and again polarity notation will be positive terminal here and negative terminal here. Modify the network by indicating voltage across these two resistances with their polarities. Now we will apply Kirchoff's voltage law through this closed loop to calculate voltage across this resistance RB. If we succeed to calculate voltage across it, current through it is known. So by applying Ohm's law, we will be able to calculate resistance RB. So apply Kirchoff's voltage law through this closed loop. For that purpose, we are assuming the direction of current in clockwise direction, and according to this assumed direction of current, polarity notation across this resistance is marked. Write KVL equation for this closed loop. Start from here. Current entering terminal is negative, so 18 volt will be taken with negative sign. Next, current entering terminal is positive, so 4 volt will be taken with positive sign. Next, current entering terminal is negative, so 4 volt will be taken with negative sign. Next, current entering terminal is positive, so voltage across RB will be taken with positive sign. And at the end, current entering terminal is positive, so 16 volt will be taken with positive sign. Now this minus 4 volt and plus 4 volt will cancel out with each other. Minus 18 volt and plus 16 volt will result minus 2 volt only. Place this minus 2 volt on the other hand side of equal to calculate voltage across resistance RB, that will be equal to 2 volt. Now using Ohm's law, we can calculate the value of resistance RB. Value of resistance RB will be equal to 2 volt divided by 1 milliampere. So the value of resistance will be 2 kilo ohm. Similarly, we will apply Kirchoff's voltage law through this closed loop to calculate voltage across this constant current source. For that purpose, we are assuming the direction of current in clockwise direction. Start writing KVL equation for this closed loop. Start from here. Current entering terminal is negative, so 2 volt will be taken with negative sign. Next, current entering terminal is positive, so 8 volt will be taken with positive sign. Next, current entering terminal is negative, 16 volt will be taken with negative sign. And at the end, current entering terminal is negative, so VA will be taken with negative sign. Now add minus 16 volt and minus 2 volt together, it will become minus 18 volt, and add 8 volt in minus 18 volt, the answer will be minus 10 volt. Place this minus VA on the other hand side of equal to calculate its value. So the value of VA will be minus 10 volt. So this was exercise problem number 2.104. Thank you. See you again in next video.